Okay, so we're going to do a couple problems from 2.5, both the lesson and from RSG. So the first one I'm going to do is this problem right here, number 11. And so I'm going to copy it because that way I don't have to squeeze it in this small space, right? So here goes this one. So the directions for this one, and I'll make it just a tad bit bigger. The directions for this one are just for you to solve. It says solve each equation for X. And so like we were talking about last time, the order in which you solve things will always use the order of operations backwards in reverse order, and you're undoing. Okay, so Ms. Johnson, what does that mean? So here, the first thing I'm going to do is I'm going to write SADMAP. And I'm looking for any subtraction or addition. So that's the very first thing I'm going to do. So the very first thing is, because I'm on the X side, I'm looking for a subtraction and addition. And I'm going to say, I don't see it. And some of you will say, oh, Ms. Johnson, but don't you see that +2? And I do, but notice that +2 is where? Yeah, number one, he's inside parentheses and he's up in the exponents. So I am going to ignore him until I get to like either of those two. Does that make sense? Okay, so done. No subtraction, no addition. Then I'm going to look for division and multiplication from left to right. And I see multiplication right there, Ms. Johnson. There's an invisible times symbol right there that I'm going to take care of first. So because there's multiplication and division, then I'm going to take care of that. So how do I undo 5 times something? Well, I would just divide by 5. So when I divide by 5, that leaves a 1 there. I'm going to divide by 5 on this side as well. And so I'm left with 0.25 divided by 5. In case you like, hey, use a calculator to make sure that you're okay. I'm okay with it. Divided by 5 looks like 0.05. And then I'm going to leave this other side exactly the way I see it. And I'm actually going to take out the parentheses there because I don't need them anymore, right? The reason why they were there was to multiply by 5. I don't need them anymore. So the next thing I see is I see the exponent. So this is where choice comes in. So either you're going to rewrite it as a log, like we did for this problem here. We rewrote this problem to rewrite it as a log. You could take the log of both sides like I did here. See the greenish, bluish log. Or you could, let's see, what else could you do? Or you can graph it. So graphing to me is okay, but I can't get very precise. I don't want to guess and check. So I'm going to, let's see, I will take the log of both sides. Okay. So when I take the log of both sides, that looks like this, right? Log. And I'm going to put a 10 there on purpose. I know I don't have to put a 10 there, but I'm going to put a 10 as my base. And you can't see it yet because my computer is catching up to us. I'm going to put the base as 10 because of this 10. Because the base here is 10, I'm going to do log base 10. Does that make sense? There it goes. So there's log base 10 on this side and log base 10. I squeezed them in there. Do you see that? Okay. So the reason, again, I want this to be a 10 is because I know that this property will kind of log base 10 of 10 is 1. And then this x plus 2 is just going to be left with x plus 2. If you want to think about it as the power rule, this guy jumps out in front. So now I have x plus 2 times log base 10 of 10, right? So then let me just write it like that. I would write my log base 10 of 10, and I would write that x plus 2 out in front like this, right? Because then everyone understands that's why when I simplify this, log base 10 of 10 is just 1, right? And then I just have the rest of this the same. So log base 10 of 0.05. And I know this looks weird, this number right here, but this is actually a number, I think some really small decimal or something like that. Okay, it's just a decimal. Okay, so then I already know that this is 1. So this is 1 right here. So then this is x plus 2 times 1. So that's just leaving me with my x plus 2 equals to log base 10 of 0.05, right? And then Now, again, my goal is I need to solve for x. So x isn't by itself. So then I have to subtract 2 to both sides. So then as I subtract 2 to both sides, then my answer comes out. And here's my answer. So answer is x is equal to -2 plus log of 0.05. Notice I dropped that 10. I don't need it. And then it says, just solve the equation for x. It didn't tell me to like give an approximate of the answer, but if I wanted to, I can. So I'm going to pull in my handy dandy Desmos calculator, my favorite, right? Desmos. Okay. Or this. Done. Okay. So then here, I'm going to plug that in. It's going to be -2 plus log, and I don't have to put 10. If you want to, you can, but there's my answer, -3.3010. So this is about -3.3010. So we'll just leave it like that. Okay, and so there's your answer. If you wanted to, you could check your answer, and I highly suggest this. So I'm going to plug this in. I'm going to say 5 times parentheses, and I'm going to plug it in exactly what I see here, 10. And then instead of that x there, I'm going to put this number here, and it's going to look funny, but that's okay. So to that, and I'm going to put parentheses around my exponent, -3.301 plus 2. Okay, and there's my answer, 0.250017. Ms. Johnson, it's not exactly the answer. Exactly, that's why we use these curly little equal signs, because it's an approximate. Now, is that close enough? Yeah, and if I was to take this whole, if I was to copy all of this, it would get closer and closer to 25. So let me just show you what I mean. So I'm going to plug in that 0, let's see, 3010299. Notice here, all those zeros are showing up after, right? So notice here, this is a lot closer to that 0.25, okay? All right, so then the next problem that they asked for was number, oh, I lost it. Number 12 and 13 from set. So I'm going to go over here to set, and I'm going to do these problems. Again, these are going to look kind of the same that I did before. So again, I'm going to copy it so I can have a little bit more space here. And then let me just copy again for number 13. New 12 and 13. Okay. So I will put this one probably over here to the right. If not, then I will just move it over. Or move it down, whatever. So I'm just going to leave it right there. Okay, so now all it says is to solve each equation and then write the answer in the log and decimal approximation. So they want both answers, just like we did for the last one. So here is me scooting this over, maybe putting it here for now. Okay, so for this one, what we're going to do first is we're going to take care of it again using SADMAP, right? I'm going to use SADMAP again. So here's SADMAP. On the x side, right? So the very first thing I notice is I see that divided by 3. I'm going to go after that first. So there's, again, there's no subtraction or addition. I'm going to go over this division and multiplication. How do I get rid of divide by 3? Well, I just multiply both sides by 3, right? Okay, and I'm going to do this kind of funny, and you're going to be like, Ms. Johnson, why did you do it this way? And I'll explain why in a little bit. So there's 10 to the 2x minus 1 equals 2. And then I'm going to leave this as 75 times 3. Now, I know what 75 times 3 is, but I'm going to show you what I like to do so that you're only touching the calculator or you're calculating later, okay? So for mathematicians, the more times, now I'm going to bring up my Desmos calculator, the more times you hit enter, the bigger your error becomes. And because we're dealing with decimals, I don't want my error to be big, okay? So I'm going to leave it as exact like this, and then I'm going to plug it all in here in a second. If you don't like to do that, then just multiply 3 times 75, which is 225, and then do your next step. Okay. So the last problem that I did as I took the log of both sides. So this one, I think I am going to rewrite this in terms of logs. So when I rewrite this in terms of logs, and I know that's my next step because everything is stuck in my exponent. So when I rewrite this in terms of logs, I'm going like this. Okay, so I go log, right? And then I look for my base. So my base here is 10. Now, because the common log already has an invisible base of 10, I'm not going to write a 10 there. Okay. And then I write this 75.3. And then I say that is equal to my 2x minus 1. Okay. Oh, and look at what I just did. I said 75.3 and it should have been 75 times 3. So let me fix that. Okay, that's because I was being messy. Okay, so 75 times 3 equals to 2x minus 1. Now, again, this looks like a big old mess, but that's okay. So here on this side, I'm going to start SADMAP all over again because technically I just entered exponent. And so it starts all over again. So do you see any subtraction and addition? So I'm going to write SADMAP again. Right? Do I see any subtraction? Yeah, I see this subtraction right here, Ms. Johnson. Okay, good. So then you're going to do that. So you're going to add 1 to both sides. And no, Ms. Johnson likes to put the 1 all the way out in front. And then last but not least, I just need to divide this whole thing by 2. So I'm going to just divide this whole thing by 2. Divide this by 2, and there goes my answer. X is equal to 1 plus log of 75 times 3, all divided by 2. So I'm going to plug this into this Desmos calculator exactly as I see it here. Okay. So here's 1 plus, okay, so I already know because this is all on the bottom, on the top of something, I'm going to put parentheses. So I'm going to go parentheses 1 plus log of 75 times 3. So I'm going to put another parentheses, 75 times 3. I'm going to close that parentheses from the top. So this looks like it. Ms. Johnson, why did you put the parentheses around that argument? Because I wanted to tell Desmos, hey, this whole thing is what I'm taking the log of. Okay, and if you want, you could put 225, I'm okay with that, divided by 2, and there's your answer. So then this is approximately, X is approximately 1.6761. 1.6761. So Ms. Johnson, how many decimals do you want me to pull? And sometimes I'll tell you here, I usually go with 4 just because that's a pretty, accurate number. So for those of you like, Ms. Johnson, why didn't you just, simplify along the way? Because I've learned that sometimes when I'm doing calculations in my head, I mess up. So if I take this whole thing and I copy it and I put it right here and I was calculating along the way, this is where I would have gotten one. I got the same exact answer. Right. If you're calculating along the way, like right here, the moment that you put log, then this would have had to been an approximate. And again, every single time you hit equals, you're making your error bigger and bigger. Okay. So there is that. So I'm going to do number 13. I think I'll do it right under. I'll put it right here. So that way we can move on. Okay, so here's number 13. I'm going to approach it the same exact way. I'm going to use SADMAP because that's going to help me figure out what I should do first, second, and third. Okay, so on the X side, do you see subtraction and addition? And you're like, yeah, Ms. Johnson, I see that plus 3. Okay, we'll subtract 3. So here I will subtract just because I showed you already how to do it without calculating. So I'm just going to make this a little bit neater. So this is going to be 2018. And then I'm just going to copy that 4 parentheses 10 to the X minus 2 parentheses, right? And then, so I'm done with that. So the next one is, hey, do you have any division or multiplication? And you're like, yeah, Ms. Johnson, I see a 4. I see 4 times. Okay, so how do we get rid of it? Well, we divide by 4. And so then I just, again, I write my 10 to the x minus 2 equals 2. And then I'm going to use my calculator because I don't know off the top of my head. 2018 divided by 4 is 504.5. Okay. Okay, so then this is still catching up to me. So let me go here, here. Very good. It's going to catch up. So now I have 10, I have this inside stuff, 10 to the x minus 2. So again, this is your choice. Do you want to rewrite it using logs? Do you want to take the log of both sides? It's really up to you. And if you notice, when I took, when I rewrote this into logs, if I took the log of both sides, you see how log base 10 of 10 would simplify and you'd be left with 2x minus 1. So it's the same thing. It's literally, it's just how your brain thinks about it. So I'm going to take the log of both sides on this one, and I'm going to, again, squeeze them in here. And because I have log base 10 there, I'm just going to squeeze in. I'm not going to write log base 10. I'm just going to write log. Okay, so this, again, log of 10 of 10 leaves me with my x minus 2 because of that one property. And I'm going to leave this as log 504.5. And then last but not least, it says minus 2. So our last step is to add 2. So x is equal to 2 plus log 504.5. So that's my exact answer. So whenever, like if your SATs or whatever say, give me the exact answer, that's you not touching a calculator and pushing logs and square roots and all the numbers that give you decimal approximations, right? So then now what I'm going to do is I'm going to plug my, my whole function in. So 2 plus log of 504.5. Let me just make sure that I plugged it in correctly. So yeah, my answer is approximately 4.7029. Good. Okay, so that's that. I hope that makes sense. Let me know if it doesn't.